This lecture introduces Chapter 14, Measuring Galaxies. Galactic research involves superlatives of mass, distance, size, number of stars, and brightness. Astonishingly, galaxies consist mostly of dark matter and most have a supermassive black hole at their centers. Chapter 14 has the following learning goals. Students will learn to determine a galaxy's type, to explain why the arms of spiral galaxies are sites of star formation, to describe the evidence for the existence of dark matter in galaxies, to explain why scientists believe that most, perhaps all, large galaxies have supermassive black holes at their centers, and to describe how we know that we live in an expanding universe and the implications of this observation. Advances in the 1700s and 1800s lead to greater understanding of the solar system bodies including comets and asteroids. In their quest to explore and map the skies, both amateur and professional astronomers discovered extended entities that were yet unexplained. One of the first attempts to catalog them was undertaken by Charles Messier. The remainder of this lecture describes Messier's catalog.
Comet Halley was predicted to return 1758 to 1759. A young astronomer in Paris, Charles Messier, joined the search in 1758. He went on to discover 20 comets, and observe and describe 44 of the 50 observable comets between 1758 and 1806. To assist comet hunters, Messier produced a catalogue of nebulae and star clusters, so that astronomers would know what objects in the sky to exclude.
Of his catalogue, Messier said, "What caused me to undertake the catalogue was the nebula I discovered above the southern horn of Taurus on September 12, 1758, whilst observing the comet of that year. This nebula had such a resemblance to a comet in its form and brightness that I endeavored to find others, so that astronomers would no more confuse these same nebulae with comets just beginning to appear. I observed further with suitable refractors for the discovery of comets, and this is the purpose I had in mind in compiling the catalogue." After me, the celebrated Herschel published a catalogue of 2000 which he has observed. This unveiling the heavens, made with instruments of great aperture, does not help in the perusal of the sky for faint comets. Thus my object is different from his, and I need only nebulae visible in a telescope of 2 feet focal length. Since the publication of my catalogue, I have observed still others. I will publish them in the future in the order of right ascension for the purpose of making them more easy to recognize and for those searching for comets to have less uncertainty. The Messier objects are visible to Northern Hemisphere observers. In total, there are 12 nebulas, 56 star clusters, 40 galaxies, and 2 other entities identified by Messier as possible sources of confusion for comet hunters. A nebula is a general term used for any fuzzy patch on the sky, either light or dark. Today, astronomers use the term nebula to classify an interstellar cloud of dust, hydrogen, helium and other ionized gases. Some nebulas are the debris created by a supernova. A supernova is the explosive death of a star caused by the sudden onset of nuclear burning, type I, or an enormously energetic shock wave, type II. A supernova remnant is the scattered glowing remains from a supernova that occurred in the past. Planetary nebulae are created by the death of lower mass stars, when as red giants, they eject the outer envelope of their atmosphere to fill a volume roughly the size of our solar system. 4 of the Messier objects are planetary nebulas. Here are some higher resolution, and more distant, views of planetary nebula. These were not included in Messier's catalogue because through his optics they did not appear to look like comets. A diffuse nebula is an irregular cloud interstellar matter composed of gas and dust within which stars can be born. Here diffuse means it is extended and contains no well-defined boundaries. 7 Messier objects are diffuse nebulas. A star cluster is a group of stars that are gravitationally bound. 56 of the 110 Messier objects are star clusters. An open cluster is a loosely bound collection of tens to hundreds of stars, a few parsecs across, generally found in the plane of the Milky Way galaxy. A globular cluster is a tightly bound, roughly spherical collection hundreds of thousands, sometimes millions, of stars, spanning about 50 parsec. Globular clusters are distributed in the halos around the Milky Way and other galaxies. A galaxy is a gravitationally bound collection of a large number of stars. Our Sun is a star in the Milky Way galaxy. A spiral galaxy has a flattened, star-forming disk component that may have spiral arms and a large central galactic bulge. A barred spiral galaxy has a bar of material passing through its center and spiral arms beginning near the ends of the bar. In an elliptical galaxy, the stars are distributed in an elliptical shape on the sky. Projected into the observer's field of view, they range from being highly elongated to nearly circular in appearance. A dwarf elliptical galaxy can be as small as 1 kiloparsec across and contain only a few million stars. Looking like an armless spiral galaxy, a lenticular galaxy is in an intermediate between an elliptical galaxy and a spiral galaxy in galaxy morphological classification schemes. In a starburst galaxy, a violent event, such as near collision, has caused an intense episode of star formation in the recent past. One Messier object is a double star. A double star system, a system of unrelated stars that are very close to each other as seen from our view at Earth. In the case of M40, the stars are unrelated to each other. There is one asterism in the Messier catalog. An asterism is composed of physically unconnected stars that appear close to each other in the sky as seen from Earth. In summary, the quest for comets inspired Messier to create a catalog of fuzzy blobs in the night sky that could fool a comet hunter. Discoveries of nebulas and galaxies lead astronomers to debate the structure of the universe. The lectures that follow explain the great debate, the size and morphology of galaxies, dark matter, and the expansion of the universe.